defining a solution. Defining a solution. Defining a solution. What's a solution? If I ask you solution, what's your opinion about solution? How you define solution, Randy? What's a solution? That's true. Can you give me an example? Like if you dissolve salt with water, that creates a solution, right? Salt and water, right? So in the solution, there are two parts basically. There are two parts. We call them solute and solvent, right? Solute and solvent. Solute is the one that is dissolved, the one that's like a minority part, the one that's in a smaller amount. Solvent is the majority part, it's a huge part, as we call it a solvent. The solute and the solvent together, it creates solution. It creates solution. Now, because we are dealing with inorganic chemistry, it's not organic. This is Chem 101, it's inorganic chemistry. Most of our solvent is going to be a polar solvent, which is water. So most of the substances that dissolve in water, they are said to be aqueous solutions. So you heard about aqueous. You remember the symbols that we use for aqueous? AQ, right? AQ stands for aqueous solution. AQ stands for aqueous solution. So aqueous solution means it's a solution in which water is used to be as a solvent. Water is a media, water is a solvent, water is a majority part. Okay. Now, we're going to classify aqueous solutions in terms of whether they are conduct electricity or not. Okay. In terms of whether they are strong electrolytes, weak electrolytes, and sometimes we call them even non-electrolytes. Okay, that's how we classify aqueous solutions. First of all, what's electrolyte itself? What's electrolyte? If I ask you electrolyte, how you define that? Yeah, it's ionic. It's ionic. Yes, it's an ionic substance dissolved in water, and it has to form ions. It has to form two different ions. Remember, it has to form a positively charged ion and a negatively charged ion. So we call that electrolytes, basically because they can carry electricity, they can conduct electricity because of the two different ions we have. Most ionic compounds, for example, sodium chloride is an ionic compound, right? It dissolves in water, it forms into ions like sodium ion and chloride ion. Magnesium bromide, sodium nitrate. The ions that are formed from sodium nitrates are, what are the two ions that are formed from sodium nitrate? Sodium ion and nitrate ion. Now, if a substance doesn't form ions in a solution, we call that substance an electrolyte. We call that substance an electrolyte. And the implication is that the solution doesn't conduct electricity. Okay? So electrolyte means a substance that can carry electric current, that has different ions, positive and negative ions. Non-electrolyte doesn't dissociate. Okay? It dissolves, be careful. It dissolves, but it doesn't dissociate to form ions. And that is tricky. Sugar dissolves in water. Right? Sugar and water, light dissolves light, they dissolve in water, but they don't form ions. Since they don't form ions, they cannot be classified as electrolytes. Okay, some of the compounds here as an electrolyte is glucose, C6H12O6. Methanol comes from methane, CH3OH. Okay?
Is it because they're all negative?
They don't form ions. They don't form ions. They can't.
To form ions, you need to have like positive and negative.
Yes, to form ions, you need to have a positively and a negatively charged ions. But we're asking, if you consider glucose, they can't form. They are molecules. Okay, they are dissolved in water, but they are molecules. They are not forming a positively or a negatively charged ions. One thing before I go to the second slide, I would like to say that, however, electrolytes also are classified as strong electrolytes and weak electrolytes. That's also another thing we need to know. Strong electrolytes and weak electrolytes. How do I know a substance is a strong electrolyte? One of the definitions is that if a substance is completely dissociated, 100% dissociation, that is a strong electrolyte. Yes. If a substance is partially dissociated, that is a weak electrolyte. That's a weak electrolyte. So it's a matter of dissociation. There is some ions completely dissociated, some ions partially dissociated. We're going to see those ions. This actually requires experiment. I mean, you have to find out from experiment based on putting the bulb in a wire, in a solution, and you can see the intensity of the light. If the intensity of the light is stronger, then you can see that's a strong electrolyte. If you can see blinking or weak light, then that's going to be a weak electrolyte. See how many ions you have. How many ions you have is going to tell you whether it is weak or strong. Okay. So this can be give us a picture about whether a substance is electrolyte or non-electrolyte. Here the substance is dissolved in water. Okay, the water molecules are here. The hydrogen and the oxygen is attached. The hydrogen part here is the middle part, the red part is the oxygen part. You can see that with other substance, maybe sugar, maybe glucose or something else. You can see that there's no ions, but they dissolve in water. The molecules of water surrounding the sugar molecule here. Over here, this might be ionic compound. This might be like sodium chloride, and you can see a positive end of the water molecule, which is a hydrogen ion, is attached with a negative end of the substance, maybe chloride ion. If you think sodium chloride is dissolved in water, that might be one good example. This is a computer-driven picture just to show you whether it is electrolyte or non-electrolyte. Yes?
A is weak and then B is strong.
No. A is example of electrolyte, B is example of non-electrolyte. Yeah. We don't know whether it is weak or strong. Okay? Well, right now, you may see that, depending on the concentration of the ions, too many ions you have is also an implication that it's a strong electrolyte. A weak ion you have, it's also an implication that it is a weak electrolyte. Okay?
Shouldn't it be the fluid part again, please?
I'm sorry?
Can we go back to this slide?
Okay. Yes.
But the iron and the positive and negative ions are not like this could be even in it. Is it have that?
Yeah, this is just, well, here what it shows you, the molecules that you have, this is a water molecule. The idea is that the water molecule is surrounding ionic substance. It can be sodium chloride, it can be magnesium chloride, okay? We're not counting the numbers here, or we're not like see how many sodium ions are attached with the water molecules, but what we are trying to show here is that, if you think about water, water is a polar molecule. A polar molecule means that you have a positive end on the hydrogen ion, you have a negative end on oxygen ion, right? So there is something called the ion dipole attraction between sodium chloride and water. So the attraction is going to be the negative end of the ion, which is chloride ion, is going to be attached with the positive end of the hydrogen ion. The positive end of the hydrogen ion, which is sodium ion, is going to be attached with oxygen, because oxygen is a partially negatively charged ions. Yes?
So what you're saying is if it's a non-electrolyte, then you can't pass an electric current through it?
Yes.
It won't.
Yes, yes.
So like if I was touching water and you had an electric current and it wasn't an electro,
Yes, you can see, you see, you can do this experiment, like for example, we can do a simple experiment in the lab. What we can do is you have electric wire, right? And then put a bulb on the top of it, dissolve sugar in water, that's an electrolyte, dissolve sodium chloride in water. You see a light, intensity of light in sodium chloride with water. The same bulb you put in sugar with water, you don't see electrolyte. So what is the reason? This is the reason here. It dissolves in water, it forms a solution, but there is no ions here.
So, because water conducts electricity.
No. Water does not conduct electricity, pure water. If you have a pure water, it doesn't conduct electricity, but water with some ions. Okay?
Will conduct electricity.
Yes, it conducts electricity. It conducts electricity.
So
There's-
still water won't.
If you have, you see, Williams, when we say water, it's very hard to define water. What's the definitions of water? You have a pure water. Okay? Now we know that water is a universal solvent. If you ask me tap water, I will tell you yes, partially it conducts electricity. Why? Because there are some ions there. Water is a solvent. Water is a universal solvent. There are some, the water that we drink has sodium ion, potassium ion, chloride ion. There's a little amount there. They are ions. They can carry electricity. Pure water, distilled water, H2O. No, it doesn't conduct electricity. If you have a pure water. But the water, tap water maybe, or the water that you get from the sea, because it can always hold some ions in it. You may see a partiality there, you may see some electrolytes there. So for a solution to be electrolyte and non-electrolyte, what is the key part? The key part is it has to have ions there. Ions there, yes. So as I said that because since we define electrolytes, we have strong electrolytes, we have weak electrolytes, and we have non-electrolytes, right? How we define a strong electrolytes? As I've said earlier, strong electrolytes are the ones that is completely dissociated. There is no return. The ions are dissociated completely. Hydrochloric acid, for example, HCl, is a strong electrolyte. You see the arrow here? The arrow is a one-way arrow. Okay? No exit. It's a forward reaction, no backward reaction. That means it shows me complete dissociation here. Hydrochloric acid is broken completely, 100% into hydrogen ion and chloride ion. There are some ions here. You can see a reversible reaction. You know, not all molecules, not all ions, unfortunately, completely dissociated. Some of them, they return back. Acetic acid, for example, is a good example. When it dissolves in water, remember, it's aqueous in water. This is also in water. There is water here. Water is a solvent, right? Some of the ions are breaking down into hydrogen ion and acetate ion. And then the hydrogen ion and the acid ion, they regroup themselves. And then they regroup themselves. And then they return back to their original position. So in a solution, you have ions, you have molecules. Here you have only ions. Here you have ions and molecules together. Which one has ions only? The top one. Which one has ions and molecules? This one. So which one is a strong electrolyte? This one. Which one is a weak electrolyte? This right here. See, weak or strong now depending on how many ions you have there. Okay? How many ions you have there. So that's how we define a weak and then a weak electrolyte and a strong electrolyte. And if there are no ions in a solution, there is nothing that we can carry electric charge. We can transport electric charge. That is called what? Non-electrolytes. It's non-electrolyte. Okay. So. Okay, let me go here. Okay, before we are trying to identify which compounds are strong electrolytes and which compounds are weak electrolytes, I think we need to make a definition of what's an acid, and eventually we're going to define what's a base also. Okay. Again, it's not a new concept to you because we discussed about acids, right? What's an acid?
Acid is acid hydrogen.
Yes, acid means it's a substance when it dissolves in water, it provides hydrogen ion in a solution. It gives away hydrogen ion in the solution. So one of the basic things in an acid is that that substance needs to have hydrogen ion. That's one of the things that you should know. Okay, and then we move from there. When it dissolves in water, it forms an acid. We have examples of acids here. Okay. Sometimes there's also, it's called the Arrhenius theory of an acid, a substance that produces hydronium ions when it is added in water. Meaning to say, water molecule is a non-polar H2O, right? When it dissolves in water, it's adding another hydrogen ion. So instead of having H2O, because one hydrogen ion is added, it's going to be H3O plus 1, okay? If you remove a water molecule, you ended up with H ion, right? So that means that it contributes, that compound, whichever compound that we have, when it contributes more hydrogen ion in a solution, we call it an acid. We call it an acid, okay? There is also some classifications of acids. So say, for example, we have acids with, if you have one acidic glucose, one hydrogen ion, we call that monoprotic. I want you to remember that, monoprotic. Monoprotic means it's an acid that has one hydrogen ion in it. There's an acid called binary acids. Diprotic acids. Okay, diprotic acids. By the way, the word binary is a traditional name. Sometimes don't get confused with bi. Binary refers is one acid. Binary refers to one acid. If you have only one hydrogen ion, yes, sir. We have binary acids. Binary refers to one, actually. Binary refers to one. We call them binary acid or monoprotic acids. Say, for example, hydrochloric acid, nitric acid, okay? Carbonic acid is not a binary, it's a diprotic acid because it has two hydrogen ion in it. It has two hydrogen ion. Formic acid, it's also a compound of binary acids. We have sulfuric acids. It's a binary acids. We have polyprotic acids. Polyprotic acids. Poly means anything more than two. Okay. Phosphoric acid, for example. What's the formula for phosphoric acid? Which one? Phosphoric acid.
H3PO4.
H3PO4. H3PO4, right? It's more than two. So we call this polyprotic acid, a polyprotic acid. So one hydrogen ion is monoprotic, two hydrogen ion is diprotic. If you have more than two, we can say it is a polyprotic acid. Now, because sometimes, one of the things I may ask you on the test is, which of these compounds is a strong electrolyte? Which of these compounds is a weak electrolyte? How do we know that? We really need to do experiment to see the intensity of the light and then determine whether this is strong electrolyte or whether it's weak electrolyte. But sometimes we have to use our intuition, our chemistry intuition, or give our prediction because, on a test, there's no way that you can do experiment, but you have to give some prediction to identify which is a strong electrolyte, which is a weak electrolyte, okay? One of the things is if a compound is water soluble and ionic, it's one of the criteria, it has to be ionic. And it has to be a water soluble too. It has to be dissolved in water. I mean, if anything is electrolyte, it has to be dissolved in water. Well, there is also another thing that we can able to define a strong electrolyte. If a compound is water soluble and not ionic, you see, we are creating confusion here. It's water soluble and not ionic. Now, the idea is that regardless of whether it is ionic or not ionic, the idea is that it has to be water soluble, first of all. It has to be dissolved in water. There's no question about that. It has to be dissolved in water, right? Why? If it dissolves in water, it has to form what? Ions. Ions, that's important. It has to form ions. Otherwise, you cannot say it is an electrolyte, let alone it is a strong electrolyte or weak electrolyte. You cannot say it is an electrolyte. If it doesn't form ions, it's not electrolyte, right? Now, we come to whether it is strong or weak. That's another thing that we're going to see. If a compound is a water soluble and not ionic and is a strong acid, okay? Now, again, you know, the strong or weak acids is depending on what concentrations they have, okay? Or we have to measure using a pH value, okay? Maybe on the test, I may not give you a pH paper or litmus paper to tell, or I may not give you a solution, okay, to tell whether hydrochloric acid is weak or strong, to tell whether sulfuric acid is weak or strong. We don't know, right? But at least we have to have some ideas. Maybe I can give you what are strong acids, okay? In most cases, experiments shows that these compounds, these acids are considered to be strong acids. Okay? This is experimentally proven or experimentally determined that these acids, what are listed here, considered to be as strong acids. Now, I always say this, it is always important to see which of these compounds or this hydrogen ion mixed with. Mostly if you see, they mixed with the halogen families. If you notice. Do you notice that?
Group 7.
Group 7, yes. HCl is a group 7. HBr is a group 7. HI is a group 7. Don't you see some similarities there? So most of the time, acids of halogen families, acids of the halogen groups, okay, considered to be a strong acid. Chloric acid, perchloric acid, right? Well, we can't deny the fact that there are also other acids, like nitric acid and sulfuric acids. We always, you know, experiment shows that the nitric acids and sulfuric acids are strong acids, even though they are not, belongs to halogen families. Okay, so in most cases, it's important to remember acids of halogen families. If you see acids of halogen family, be careful. What kind of acids are they? The strong acids. Now, if they are strong acids, the implication is that they are also strong electrolytes. They are also strong electrolytes. See, now you can answer two questions. You know what strong acids are, and at the same time, you know what strong electrolytes are. Okay, strong electrolytes, by definition, is they can be completely dissociated, 100% dissociation. Okay, don't be confused with the trick. Dissolve and dissociate. Okay, ionic compounds, they dissolve in water, and at the same time they dissociate into ions. Non-electrolytes, they dissolve in water. Sugar is a non-electrolyte, it dissolves in water, but it's not dissociated into ions. So dissociation and dissolve are two different animals here. Okay? So just to give you an idea.
So,
Yes.
I'm not clear with the slide before this, because we are saying that if a compound is a water soluble,
Let me go back
not
with that.
ionic.
Here, okay.
Next.
Okay.
If a compound is a water soluble and is not ionic, it is strong acid.
Yes. What's your question?
And we are saying that strong acid is strong electrolyte.
Yes. Yes, that's what we say. Right? I'll give you an example. For example, hydrochloric acid, right? Now, is hydrochloric acid is ionic or not?
It's ionic
Why?
because chlorine is negative
Okay.
and hydrogen has positive charge, and both they are ionic.
Yes, technically speaking, yes, but a hydrogen ion is a non-metal, right? Hydrogen is a gas, right? Chlorine is also a non-metal, right? So, ionic compound, the correct definition of ionic compound would be like a positively charged ion reacts with a negatively charged ions, right? But hydrochloric acid, even though it has two different charges, it's not ionic. It is a covalent compound. It's a covalent compound. So that's why we have a point here. It's not ionic, but it's soluble in water. Okay? Nitric acid, HNO3. There's no metal there. Hydrogen gas is one side. Nitrogen is ionic gas. Nitrogen is not a metal. Oxygen is not a metal. Okay? It's not ionic, but it dissolves in water. It dissolves in water. In fact, it is a strong electrolyte because there is a complete dissociation into it. Williams, you have a question?
No.
No? Okay.
About dissolve and dissociate, can you say one more time which one is dissolved?
Yes. You know, substances can dissolve in water, but not necessarily they can form ions. Okay? Sugar is dissolved in water completely. You can put sugar in water and you stir it, it dissolves in water. No problem. But it's not dissociated into ions.
Maybe like dissociate, it's like...
Dissociation is breaking down into
ion.
ions. Yes, it's breaking down, but then it doesn't form an ions. Sodium chloride dissolves in water and it dissociates.
It turns to ion.
It turns into the ions. Now, if a compound is water soluble, again, water soluble is a condition here, and is a strong base. Okay, now, what is a strong base? In most cases, what's a base, by the way? If we define a base, we define acids, right? A base is the substance that provides OH ion, hydroxide ions in a solution. OH ions or hydroxide ions in a solution, that's called a base, okay? Now, we also need to find out a strong base, okay? I may have a list of strong bases for you here. Strong bases are mostly bases of alkaline metal hydroxides or group 1A metal hydroxides. Again, you have to go back with chapter 2. Chapter 2. Go back with what are group 1A? Group 1A, or alkaline metal hydroxides. What are they? Lithium, sodium, potassium, rubidium, cesium, francium.
Bro, is it like, when you say like group 1A metal hydroxide, it's like OH, Li?
Yes, that's for example NaOH, LiOH.
Anything with the OH?
With the OH, yes. They are strong electrolytes. Okay?
Exactly, we are saying that in addition to the group 1 and
Group 1 in metal hydroxides and also group 2, some of them unfortunately. Calcium, strontium, and barium, not all of them. Calcium, strontium, barium. Calcium hydroxide, strontium hydroxide, and barium hydroxide. Okay? You have to somehow remember this. Now, you know what strong bases are? By default, they are also strong electrolytes. Okay? And also we have weak bases. The most common weak bases are ammonia, for example. Ammonia is a weak base. You have done this experiment when you have ammonia. You remember from experiment 4, I think, or 6, I'm not exactly sure, but you dip in a pH paper and then you have the ammonia. And then you can see very light color, right? Like light blue color. Very light, weak blue color. Okay, blue color is actually an indication for it is base, right?
so can we say that strong base is strong electrolyte?
Yes, that's what we say. Strong bases has to be strong electrolytes. Strong acids by default has to be strong electrolytes. strong acids. That is the reason that we want to deal. You see, the idea is why we need to know about strong electrolyte or weak electrolyte. If we know strong acids and weak acid, it's also an implication that we know strong and weak electrolytes. We have weak bases. Weak bases are weak electrolytes. Weak bases are weak electrolytes. And for example, ammonia is a weak base. Well, ammonia is a gas, okay? But ammonia reacts with water. It gives you ammonium hydroxide. When ammonia reacts with water,
Hey, all right. Well, I'll talk to you when class is over.
okay,
I'll just wait out.
okay, all right. Which reacts with water, it forms hydroxide ions, right? So the dissociation is like 1%. It's not complete dissociation. Okay, 99% is not dissociated. So you have few ions than non-ion molecules. So that is makes you a weak electrolyte. You know, if I explain to you a strong electrolytes, strong acids, it's also important to know weak acids at the same time. Weak acids, like you see carbonic acids. Carbonic acids. What's the name of these acids here? Sulfurous acid. Sulfurous acid. Acetic acid. Phosphoric acid, unfortunately, is a weak acid. Phosphoric acid is a weak acid. Now, you remember, sulfurous acid comes from where? From sulfuric acid. From SO4. Carbonic acids, they are not completely dissociated in a solution. So, if you see these acids here, these are weak acids. And then at the same time, they are weak electrolytes. Weak electrolytes, yes.
Now, is that because that like the sulfurous acid is a sulfate? It has a sulfate, and sulfate
Is a common polyatomic ion.
and
The
then-
stronger common polyatomic ion, we have sulfuric acid. That comes from here.
Now the carbonic acid.
Carbonic acid, yeah.
It doesn't fully dissociate because carbonate doesn't really. It's not soluble in water. is it?
Carbonate, yes, carbonate is not soluble in water. That is, carbonate is actually soluble in alkali metals like sodium, potassium. But, carbonic acid, somehow, when it dissociated, it doesn't form carbonate, but it rather forms carbon dioxide because it's more stable. Carbon dioxide in water, And then you can't see too many ions there. You can't see too many ions. You see, the idea of weak or strong is a matter of having infinite number of ions or a matter of having less number of ions. So carbonic acid, when it dissociated into what? It dissociated into water and carbon dioxide. Few of them, maybe 1% or 2%, gets into carbonic ion and hydrogen ion. Okay, so that is like a weak electrolyte. It's because
So
of
what is
matter-
sulfurous acid break down into?
The sulfuric acid is forming into, you see, when sulfurous acid is decomposed, it forms into water and sulfur dioxide. These are the most stable compounds. But some of them, they change it into hydrogen ion and sulfide ion, which is SO3 minus 2,
So mostly they break down
into sulfur dioxide.
dioxide
And water, because sulfur dioxide is more stable compound than sulfurous acid. So, right now, what we need to know is, if you know these are strong electrolytes, right? The rest of the acids are weak acids. Weak acids means weak electrolytes. And for you, which is important, is to find out, is it an acid or a base? Is it an acid or a base? If it is an acid, what kind of acid is it? Is it a strong acid or is it a weak acid? That's another thing that you have to ask yourself. If it is a strong acid, then the implication is that what? It is a strong electrolyte.
Is it a weak acid?
A weak electrolyte. Yes. It's a weak electrolyte. Yeah.
How are we supposed to know if they're weak? If we just see them, how are we supposed to know if they're weak acid?
Yeah.
Study.
You just have
This
to
is what it
memorize all
said.
this.
Yeah, well, I don't have any choice.
You just have
You
to
know?
memorize all this.
Yes, it's very hard. I mean, we pick, now remember, this is a fraction of fractions right here. I'm just giving you 10, maybe 12. I mean, there are million acids there. Okay? You can generalize that. We just say acids of halogen family. By the way, it's not only acids of halogen families. You can have, if you Google, if you make a search, you can have infinite number. But if you see acids of halogen family, your prediction, in most cases, 99% or 98% is a strong acids. And it's a strong electrolyte.
Could you
Yes.
ask us the question in the test about acid other than these that you gave us now?
I'm going to focus with this. Okay? Okay, I'm coming. Okay, go ahead.
But none of this right here, the HCl, whatever, the strong acid or weak acid, is not ion. Right?
I'm sorry.
Like all of this right here, none of this right here is not ion. Because you have a hydrogen in the
I know, but these are just parts of acids. But remember, we have also ionic compounds. We have ionic compounds. Ionic compounds. Most ionic compounds are strong electrolytes. Strong electrolytes, and they dissolve in water. So we consider.
You see, like,
Yeah.
you see this one, your compound is only not ionic, and then you have to be like strong acid to be strong. But
Yes.
none of this right here is the ion.
None of these are ionic. Yes, they are
So,
not.
like,
Now, your question is here or here?
no,
On the top.
on the top and the bottom.
Well, they are
I don't
ionic.
know, this one, the bottom one, weak acid.
Weak acids, yes, they are not ionic. Yes.
State of hydrogen.
Yes. Yes.
Can you say that monoprotic acid would almost always be a strong acid? Can you say that
I
for the
don't
most
want to
part?
use that definition, Williams. I can't say, well, according to the halogen group here, yes. According to what we have here. But if you ask me, how many monoprotic acids are in the world? Do we know? We don't know. So, according to acids of halogen groups, yes. And no. And no. HF. Hydrogen fluoride. Did you see HF here, unfortunately? HF, you don't see it. Hydrogen fluoric acid is unfortunately, it is a weak acid. Why? I don't know. I don't know. That sometimes things are not, you see, we can't give a definition. All monoprotic acids are strong acids. Good example is HF. So we need to focus on what we know here. It's very hard to generalize, to give a general definition.
So it's more important focusing your PowerPoint than say the book.
To pass this class, yeah. For the knowledge, you have to make further research. Yeah.
Okay, what's an example of a strong acid that's ionic? Can you give us-
Strong acids and ionic.
Is it possible to be like strong acid?
Strong acids and ionic. No, there is no. There is none. There is none. What's an acid?
You have to have a hydrogen. So
There's
it can't be
hydrogen
ion.
ion. So if there is hydrogen ion, there is no ionic compound. We can't define it's an ionic
When you said
compound.
strong electrolytes are if a compound is water soluble and ionic.
Yes. Yes. If a compound is water soluble and ionic.
Oh,
No,
okay.
one methyl hydroxide.
That's only for B.
Yes.
Okay.
Yes. We have sodium hydroxide, for example. For example, I can give you this example here, calcium hydroxide, right? How do you define calcium hydroxide? It's a base. You agree with me? Calcium hydroxide is a base. Calcium hydroxide is ionic compound. So, ionic compound, and it's also soluble in water, and it's also a base. It's also a strong electrolyte. It's also a strong base. It's also a strong base. It requires like a system of studying it, I think. Okay, here are the list of, maybe this might answer your question. A base is a substance that produces hydroxide ions when it is added in water. These are strong bases, you can see it here. We have also weak bases. Now, maybe you might ask me, wait a minute, wait. We are really against the definition. Carbonates are also considered to be as a weak base, unfortunately. Base is literally, base means a substance that provides hydrogen ion when it dissolves in water. If you think about carbonates, when it dissociated, when it mixes with water, when it forms aqueous, one of the more common ions formed is a bicarbonate ion and hydroxide ions. Okay? The carbonates, you don't see carbonates per se, but you see bicarbonates and OH ion. What it means is, still it contributes OH ion. Whether we like it or not, it contributes OH ion. Then, this compound is considered to be what? A base. A base. But the question is, what kind of base is it? It's going to be a weak base. You don't see ammonia, just if you think about ammonia as a base, but when ammonia mixes with water, it forms ammonium ion and it gives away what? OH. It gives away OH. It provides OH to the water media. It contributes OH ion. We consider them as a base.
What about if we take
It's
the
a weak base, right?
bicarbonate to the next step? Can we consider that is?
Yeah, you have the bicarbonate here, and then the rest of the products, that's what we're looking for. The rest of the product is hydroxide ion. So the hydroxide ion, if a substance donates or gives away the hydroxide ion, we consider that as a base. It's a base. But the question is, it's not a strong base, it's a weak base. And by default, it's going to be also a weak electrolyte. It's going to be a weak electrolyte. So, okay.
So if you have a hydroxide for the product, it's still weak.
It's a base, yeah. It's a base, but it's a weak base. Mostly, now here's what you need to do for Friday maybe. You need to study what's an acid, what's a base, what's a strong acid, what's a strong base, and what's the difference between electrolyte and non-electrolyte. At least you can provide example of a strong and weak electrolyte and non-electrolyte substance, okay? Try to summarize this, try to focus this, and then maybe we can continue more on Friday.